A key part of this episode will be deciding which items can be stacked and which can't. We already added our variable inside our struct, if we can find that, blueprints, structs, item data, for max stack amount. And then, if you remember, we refreshed our master item and opened up our one item that we have. Let's find that real quick. It's in actors, inventory. Right, we have 2 items now. I forgot we made another one last episode. And we set the max stack amount. For flashlight battery, we set it to 8. And door key, we set it to 1. Setting it to 1 will be the equivalent of not being able to stack items in our game. So let's go to our W inventory slot. If you remember, that's in content, UMG, inventory, W inventory slot. In fact, I'm gonna start closing some of these. I'll close these, the controller. I'll leave these 3 open, and I'll close all of these for now. And here, this is where this overlay comes into play. If you remember, last time I said we had to put it instead of just putting the image. And this is because we need to add some text letting us know how many items we are currently holding. So let's go ahead and add a canvas panel to our overlay. And let's make sure it fills the entire thing. And then we want to add a text block to the bottom right. Oops, let's add that inside the canvas panel. And we want to add this to the bottom right of our icon. But first, let's wrap this with a size box so we can directly control the size a little easier. So let's right click, wrap with size box, and that puts a size box as a parent of our text block. And our size box, let's make it 30 by 15, and we're going to anchor it to the bottom right. So let's set our position X and Y to 0, and this will put it on the wrong side, but like always with the alignment, instead of making it 0.5 by 0.5, we want it on this corner now, so it'll be an X value of 1 and a Y value of 1, and now it's inside our image. I'm sorry, canvas panel. I'm also going to offset this by 5 so it kind of stays inside this gray area of the entire icon. So let's grab the size box and let's add 5 or -5 and -5. So let's select our text now and let's type in 0 for the text just by default. We can change the font to our new font, Calibri, and I think I'll make it maybe light. And let's bring the size down to 10. Let's align it to the right side and then the center of that. So that way, as the number increases, it goes to the left. So if we keep adding zeros, you can see it now goes to the left. See? Let's change that back to 0 by default. We can also turn off the shadow offset so it centers itself a bit better. And we can compile and save, and we can press play to make sure it looks good. If we hit tab, and we have that 0. I think I might offset it just slightly more so it's not quite as close to the gray. So let's grab our size box, and let's make this something like -7, I'd say. -7. Okay, let's test that again, and I think that looks better. Or maybe like -6. I don't know. It's completely up to you. The fun part is just to tweak and make it look like something you want. Perfect. So let's grab our text here and let's make it a variable. So let's call it amount text and make it a variable. And we want the default visibility to be hidden. And let's update this in our update slot event. So we can just go up here to our update slot, and after we update our slot image, we can get our amount text, and then we want to set the text, so set text, and we'll get this number from the get item data at index. We just take this amount and we'll plug it in there, and it will automatically change it from integer to text. And we can open this up to mess with the details. First, we can toggle whether we want to use grouping, and grouping is adding commas for larger numbers. So if we go over 1,000, if we do select use grouping, it'll add a comma after before the first 3 zeros. And if it's off, there will be no commas. The minimum integral digits, this is the minimum digits that the number can have. So if it's 2, and say our amount is like 5, instead of writing 5, it would write 0, 5, because it would have a minimum amount of digits to 2 instead of 1. But I'm going to leave this at 1. So we can close that and compile and save. So after this, we want it to make the amount text visible if we have more than 1. If we have just 1, I don't want the text to show up, so we can just get a set visibility, and the target will be our amount text. We'll just plug it in from there, and we can get a select node from this. And the index here is just if this amount is greater than 1. Plug it into the index. If that's true, we'll have it visible, and if it's false, we'll have it hidden. Compile and save. So we can actually test out if this works. So let's hit play, and here we have our battery. We pick it up, and we have 10 batteries. If you remember, click right here. The amount is set to 10, and here the amount is set to 1. So we pick up our 10 batteries, and we have 10, and we pick up our 1 door key, and there is no number because we don't show a number if it's 1 or less. But we also need to add ability for stacking. As you can see, I just picked up the other battery, but it adds it over here instead of adding it on top of this one. Well, this one would have to go to 8 and then 2 because the maximum stack is 8, but we'll fix both of those things. So let's go into our BPC inventory, and in add item, I'm just going to scroll out here. We just want to check if the max stack amount is greater than 1. And if it isn't, we just want to do all of our old code here. If you can only pick up 1, we just want to check for an empty slot because there's no reason to check for stacking. So we can just pull this down, create a new if statement, and we can check if max stack amount is greater than 1. And we'll put that in condition, and that's if this is false, we want to continue to just finding free stacks. There's one more thing we'll have to add to this path to avoid a bug, but we'll come back to it. On the true path, we need a function to search for a stack with room. So let's create a function called check for free slot. We just want to check for a slot that has room. So for example, the flashlight battery, if it has a stack that is less than 8, because 8 is the max stack amount. So let's create an input, and it'll be of type item. It'll just be our BP master inventory item master class reference. And we just want to add a for each loop with break for the inventory slots, because we want to first see if we can find the item that we're looking for, and then we'll check if it has room in it. So we can break the array element, and we just have to check if the item is equal to our item input. Create a reroute node. Then we want to add an and, because we want to make sure it also has room. And we want to check if the amount is less than the max stack amount. So the item, we have to get the class defaults, and we can split this and make sure our amount is less than our max stack amount, and we'll plug that into the second condition of the and. We want to have 2 local variables, local success, which is a boolean, and local index. And this is an integer. And let's create a, oops, didn't mean to open that. Let's create a if statement and plug that into the condition for the branch. And on true, if we do find it, we want to set local success to true. And on false, we want to set a local success to false. If we did succeed, we want to set the local index to the index that we found. So we'll plug this index into the array index, and then we want to break the loop. So just add reroute nodes to make it more clear of what's going on. And then on completed, we just need 2 outputs. So let's select here. And the outputs we have, I'm just asking if it was a success, type boolean, and what our index is of type integer. Plug that into completed, and we can just plug in our local variables for these two. So let's add this to our add item function. So if the max stack amount is greater than 1, we want to check to see if we have a free slot. Plug that in. And the item we're checking is our local item right here. We want to ask if it's a success. So we'll ask if success. Because if it isn't, we want to look for a empty slot instead of just giving up. And if it was a success, we want to add it to that slot. So if it's false, we just want to copy this check for empty slot, and we'll ask an if statement off that. And if this was false, if we weren't able to find a free slot or an empty slot, we'll have to add a return node with the success being false. Let's add a second output to our return node. So we type integer, and this will be called remainder. And we need a remainder output just in case we can pick up some of the items. So we go here, see how this is amount is 10. Let's say our inventory is completely full except for the last slot, which has 4 batteries in it. We pick these up. We want to be able to pick up 4 out of the 10 batteries to fill the last slot, but keep the remaining 6 on the floor. So we need to know what our remainder is, which would be 6 in this example. On this path, however, the remainder would be the entire amount because we were not able to find a free slot or an empty slot. So we'll just plug in our local amount to the remainder. And since our return node changed for these two, for this one we also want to add local amount for our remainder because we were checking for a free slot and we did not find one, so we don't pick up anything, so our entire amount will be our remainder. And on the true path, where we do add it to an empty slot, our remainder would be 0. So off the true path here, we want to set our local index. We want to update it to this new local index, because if it's true, we want to add it to an empty slot. And then we have to check if the amount is greater than the max stack amount. Because if the amount is less than the max stack amount, we don't have to worry and we can just add all of the items to the new empty slot. But if it's more than the max stack amount, we kind of have to call this whole thing again after adding in the max stack amount, for example 8, and then saying if you had like 2 left over, you have to call this again and then recheck for a free slot, recheck for an empty slot. If you find one, you can add those 2 to that one, and if not, they are left on the ground. So let's just get our local amount, and let's ask if it's greater than our max stack amount. And if it is, and since this is going to branch off again, we can pull this down just a bit more. If it is, we only need to add the local max stack amount to the inventory slot, and not the local amount. So let's do the easier path first, which is false, if our local amount is not greater than, because then we can just add the entire local amount. So we'll set an array element. The target array is our inventory slots. Index is local index, which has now been updated to this empty slot. The item, we can split this, and we can plug in our local item and our local amount. After that, we just want to update the inventory slot, add our local index, and then we'll call a return node, and success will be true, and our remainder will be 0. Now off the true path, oops, let's fix that real quick. We want to set the array element, and inventory slots will be our target array. Our index, once again, be our local index. And for item, oops, I promoted that to a variable. Did not mean to do that. Can delete it. Split the struct bin. The item will be our local item, but the amount will be our max stack amount. And then we will update the inventory slot. I'll just copy and paste this right here. And then after that, we want to call our add item function again with the remainder of our local amount. So we'll call add item, and our item will still be our local item, but the amount will be our local amount minus the max stack amount. And then we will call a return node, and we want to check success, because this specific index of adding the full max stack amount was a success, and the remainder we want to plug in from our add item. So let's go back to one of our first branches here. And what if we did find a free slot? All of this was only if we didn't find any free slots. Now we need to know what to do if we did. So if we did, we want to set, or we can just drag it in, we want to set our local index to this new index that we just found. And we need to add our amount, our local amount, to this slot with the item already in it, or our free slot. So let's get the item data at index from the local index. And we want to add this amount to our local amount. Oops. And we're not actually setting this to be our local amount, because that wouldn't make any sense. We're just doing this to check and see if it's over the max stack amount or not. For example, if we do find a free slot, and it has, say, 4 batteries in it, and we pick up 8 batteries, we need to check to see if 4 plus 8 is greater than our max stack amount, which is 8. So 12, which is the local amount, plus this amount, is greater than the max stack amount. So if it is, we only need to add the first 4 to this slot, and then with the remainder, we want to call this again to check for a free slot and check for an empty slot. So let's ask if the result of the added amounts is greater than the max stack amount. Let's create an if statement right here. And we can start pulling things down again. Just create some room. And if it isn't greater than the max stack amount, then that's perfect. We can just add the amount and we're done. So let's do that first. So off the false pin, let's set the array element. And we want inventory slots, local index, split the struct bin here, get the local item, and the item amount will be this added amount here. We want to get the amount we already had plus the local amount. After that, let's update our inventory slot. I can just copy and paste this one right here. And add a return node with success checked, and the remainder is 0. If the amount is over the max amount, however, we need to do something different. So let's set the local amount to the added amount. Oh, I'm sorry, not just this. We want to set it to the added amount here minus the max stack amount. So let's set that array element. We can just copy and paste this right here. And we just want the local max stack amount for the item amount. So this fills up the free slot that we found. and then our new local amount is that amount minus this amount, and then our new local amount is these two added together, but with this subtracted from it. So let's update our inventory slot. And we want to recall the add item with our leftover amounts. So let's call add item, and local item for item, and local amount for amount. And this is our new local amount after we've done this math here. So let's call a return node. And we want to check success because adding this local max stack amount was successful. And our remainder will come from our remainder in add item. Cool, that should all be set up. Now let's fix that small bug I mentioned earlier in the path for non-stackable items. So just to go from the beginning, we set all our local variables, and we ask if the max stack amount is greater than 1, and if it's not, if it can't be stacked, we ask if it checks for an empty slot. And instead of adding our local amount, we only want to add 1. So we can actually delete this. And the bug that I was talking about is essentially if you have this item with the, it's our door key. If you remember, we set our door key to have a max stack amount of 1, so it can't be stacked. If we were to set this amount to something higher, like 3, we'd want this to disperse across 3 inventory slots. With the way we had it, with if this had just been local amount, it would have defied the max stack amount number and would have just added 3 to 1 slot. So instead, we only want to add 1. So after we update the inventory slot, we want to subtract 1 from our local amount. So we'll get local amount and we'll subtract 1. And then we just have to check if this is greater than 0. And if it is, if we still have items, so for this item specifically, we would have picked up 1, and then we would have subtracted the amount, so it would have become 2. And is that above 0? Yes. So if it is, we want to recall the add item function, so it can just go through all of this again. And if it's not, we just want to stop it. We just want to pick up our item and be done. So we'll just ask if this is greater than 0. Put that into a branch. And if that is false, we just want to call a return node with success being true and a remainder of 0. But if it's true, we want to call add item, and it'll be our local item. And the new amount will be our local amount minus 1. Great. And let's create one more return node. And the success will be successful, and remainder will go into remainder. Our add item function is fully set up. I hope you were able to follow along with it because it gets pretty complicated, but I did my best to explain everything as thoroughly as I could so you could understand kind of how this branches out and how it works and how it decides where to place each item. There's one last thing we should do before we test it, is to make sure not to destroy the pickup actor if we can't pick it up. So if our inventory is full and we can't pick it up, we don't want to destroy this actor. So we have to go to our pickup actor. So it's in inventory, pickup actors, master. And, oh, I forgot, we already put the branch in. I guess in my notes I did it in a slightly different order. But we also want to update the amount that this pickup actor is holding after we call the add item, and that's why we have this remainder output. Say if your inventory is almost full, but you have room for 1 of, say, these 10 batteries, and it picks up 1, we want to update this so it changes to 9. So if we did pick it up, which means this true path goes, we need to check if we picked all of it up or just some of it. So we can just create another if statement here, and we can just ask if the remainder is greater than 0. And if that's true, we don't want to destroy the actor. We do if it's false. If it's not greater than 0, it means we picked up the entire thing and our item is gone. We destroyed it. If it's true, though, we just want to take our amount variable and we want to set it to the remainder of our add item. And we can compile and save. All right, time to test our code. Let's make, here, let's move this over here. And let's make 3 of these flashlight batteries. Let's give the first 3, and the second one 4, and this one 5. And let's get this door key, and let's keep that at 3. So let's test this out. So obviously when open our inventory, it's empty. So when we pick up our first actor, which is 3 flashlight batteries, it won't find a slot that already has batteries. So it'll put it in the first empty slot it finds, which is our first slot. So let's pick it up. And we can see this now has a little number 3. We have 3 batteries right here. Now, when we pick up these, we have 4 batteries. It will search again for a slot that has batteries, and this time it'll find it. Our first slot does have batteries in it, so it'll add these 4 to our slot. And now it says 7. Now we have 5 batteries left, but our max stack size is 8. So what it should do is add 1 to our slot that it finds, and then the next 4 to the next empty slot. So let's pick that up and see if it works. And there we go. We have 8 here and 4 in the next slot. Now for the 3 door keys, these are unstackable, so when we pick them up, they should take up the next 3 slots. And they do. Great, so let's bump up our door keys to something like 9. And remember, we only have 8 inventory slots, so we don't have enough slots to hold 9 door keys. So when we go up to it, the actor won't disappear. And it'll say no free slots because that's a debug we added a long time ago. And now when we open our inventory, it's filled up the first 8 slots, or all 8 slots, with door keys. This amount here has changed to 1. There's only 1 door key on the floor now instead of 8. Great. And I guess last thing we can test is very similar to the one we already did, but if we change this to something like 10 and pick it up, it should put 8 in here and 2 in there. So it's able to do it even if it starts at a free slot. Alright, so now we are able to add multiple items in every single way. I'll see you in the next one where we work on disabling empty inventory slots.